Okay, previously, I did this example for 104 inverse functions. And the functions, as they turned out, made it kind of difficult to keep track of things. And I made a couple of mistakes, and it turned out not to have been a good explanation. So I'll have to address that one a little bit later, probably in a separate video. But I will address, this is actually a pretty easy problem if you see it, but I'm sure I haven't done it enough. Try to do that later. 105 is on inverse functions. Again, we're looking at copy of version 4 of the sample problems that I sent you. And this one is pretty straightforward. Everybody, I think, is in pretty good shape with this. But you have function f of x equals negative 4x minus 4. What's the formula for f inverse of x? Well, if we let y equal f of x, which is minus x squared minus 4, then that gives us y equals negative 4x minus 4. What's the big deal with inverse functions? Well, the thing I told you to remember, swap x and y. So we take this equation and we swap x and y. So x becomes y and y becomes x. And now solve for y. Okay, let's write it out again. X equals minus 4, y minus 4. Now, people are pretty good with linear equations, so I'm just going to, if I add 4 to both sides, this 4 goes away. I get x plus 4 equals 4y. And let's just switch things around. 4y equals x plus 4. So the thing we're solving for here, solving for y, so we divide with dots here. You want to put intermediate steps in here. But instead of my time, well, not so much my time, your time, we see that the solution is y equals x plus 4. Now y equals x plus 4 over 4. Now you're asked to verify by composition. What's that mean? Verification means and actually, I'm going to say test, I'm just going to say verify. F inverse of x equals x, and f inverse of f of x equals x. Okay, well, f of f inverse of x equals what? Well, f of x is negative 4x minus 4. Well, now we've got f of f inverse of x, so x has been replaced by f inverse of x. So we're going to replace this x by f inverse of x, and it's negative 4 f inverse of x minus 4. I don't recommend at this stage that you skip this step where you rewrite f of x equals negative 4x minus 4 as f inverse of x is negative 4 f inverse of x minus 4. It's real easy to confuse these symbols and do make careless errors so things don't work out. You want to write this out. Now, f inverse of x is x plus 4 over 4. We just found that by swapping the x and y and solving. And then we have minus 4. That equals x plus 4 is negative. So something is wrong here. Okay, my solution was incorrect. This is not going to work out. There should be a negative on this. Negative x plus 4 minus 4. And it's not going to give you x. You're going to get a negative 4 here, and a negative 4 here is negative 8. You're going to have negative x minus 8. So what did I do wrong here? As I commonly do, I didn't write a negative sign for my negative. Okay. So what I get is negative 4y equals x plus 4. So I'm going to have to divide both sides by negative 4. And now we corrected this. We're going to get the negative of all of this. And I'm going to rewrite that. It's just a little hard to read. First place, x plus 4 or negative 4 is the same as negative x plus 4 over 4. So that f inverse of x is the negative of x plus 4 over 4. Now, if I plug this in, I have a negative sign in front of my x plus 4. That x plus 4 over 4. In a negative times a negative is positive. The 4 divides 4, giving us 1. And we end up with x plus 4 minus 4. Well, we don't need the parentheses. And now we've got 4 minus 4 equals, like our expression now equals x as it should. So you see that in verifying my incorrect solution, it didn't verify. I didn't get x. I knew something was wrong. I really made that mistake. I make a lot of mistakes with negative sign. I get careless. I need to focus on that a little more. And of course, you need to focus on it because negative sign errors are probably the most common errors people make without. If you're checking yourself, it's usually pretty easy to spot the error and correct it, as I just did. Okay. Now, f inverse of f of x equals what? Well, f inverse of x is negative x plus 4. So if I replace x by f of x, this becomes negative of x plus 4 over 4 plus 4 over 4. And I substitute on again because f of x is 4x minus 4. So don't do like I do. I've been at this for a while. Apparently my brain started to shut down. Okay. F inverse of f of x is negative 4 minus x. F inverse, here's the formula. So if I replace x by f of x, I get negative f of x plus 4 over 4. So you see, I started to skip a step there and I messed it up. Okay, so be careful. Okay, so then we get negative, we can now replace f of x with negative x plus 4 over 4. And then I'm replacing f of x with f inverse of x. My attention seems to be down here, and rather than up here. F of x is negative 4x minus 4. So it's negative of negative 4x minus 4 plus 4 over 4. Well, negative 4 plus 4 is 0. We have the negative of negative 4x over 4. Well, that's a negative of a negative, which equals 4x over 4, which equals x. So as I've demonstrated, a counterexample, be really careful when you write these out. Okay. if you're trying to skip steps, you can screw up. I just didn't. In each case, I saw that what I was getting was never going to give me X, so I went back and looked. So there are two things that could have been wrong. First place, this solution could have been wrong. And it was there for a little while. I discovered that when I tried to use this solution here. Didn't get what I wanted. So I fixed this, and now we use the repaired function, F inverse of X, plug in the F of X function, simplify, and we get X. And again, you want to be careful. You're plugging in the expression for F of X here, and not the last expression I fell on, which was the expression for F inverse of X. So just be careful, keep your wits about you. Make sure you get X here and get X here. Work a few of these examples. They're quick and easy. But I want you to see, you swap X and Y, you get all this. And having done that, you have these two conditions to verify that you have an inverse function. Okay. Now, next question is, you're going to construct a piecewise function. So you have three functions, F1, F2, and F3. So I'm just going to kind of note, because you can read it. What you're told is F of X, F1 is, I think, the reciprocal function. We make sure that's our toolkit exponential. F2 of X is the squaring function, toolkit squaring function. And F3 of X is your toolkit reciprocal. Okay, now I say we're going to construct a graph of a piecewise function. Now I should maybe mention here that we would want to use a 4x4 rectangle, except there's a little bit of problem with that in some cases. I'll demonstrate that. Okay. First of all, though, we're going to do a 4x4 rectangle for the. Okay, the other part of the instruction is you're supposed to just use two of these. You could use all three, but you want to use at least two. That's the way it's stated. Excuse me a minute. There's something on the. No, that's the mouse. I want to move that away. It looked like a chalkboard when I looked back at the screen. Okay, so again, we want to use. Okay, that's the computer here. We want to use. We're going to use at least one of these functions. You might choose to use this one as well. But you're supposed to use at least two. You don't have to use all three. We're going to put the red dot here. Got something that's kind of red. Connect beside that. Then we can do structure lines. By now you should know what the construction lines are. We'll do the construction lines, the exponential or squaring. Turns out we want to do the reciprocal function. Well, we're going to have to do something a little different. And I'll show you that. Now there are the construction lines for the exponential function. We need one more construction line for the squaring function. You understand that function. This line is just there so we can skip it, so we can follow the rule. Okay. Now, what I would do is I would just start out by sketching the toolkit exponential and spark functions. So the spark function is here, over 1 down 2 here, over 1 down 2 here, and then over to the red dot, then over 1 up 2. And notice that's why I have this line here that we don't have a point on. It's there to be skipped so that the algorithm works. Okay, then over 1 up 2, over 1 up 2, right here is like graph, the square function. Then the exponential function. Point here on the third, actually fourth construction line, fourth horizontal construction line. You would not use this fifth line, but your point is going to go here. That is just on. Over. Well, that's. Let me take a quick look at what I've done here. I'll do it off camera. I'm looking at a cross-eyed, I think. Okay, now what I was trying to do was over 1, up 1, and all that stuff. We do go over 1, up 1 here. But we need to do this for the exponential lines. Remember, when you do the exponential function, you don't have this line here. You have this line, and this line, and this line. Only got 3 lines in the middle, because you only go halfway on each side. Okay, so that only these lines count for the exponential function. So we put a point on this line. Now it's probably a little bit over. But then we go over 1 exponential line up 1, over 1 up 1, over 1 up 1. And now we have curve the exponential. Okay. These are the toolkit functions. So you want to be careful about what you do. If you do over 1, up 1, 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 you end up here, and you know that's not right for the exponential function. So you want to fix that by distinguishing the lines that you would use for the exponential function one by another. Okay, so anyhow, there are the 2 functions. I'm just going to go over 2 functions for right now. Now you're given 3 intervals. Okay, you're given the x intervals. Let's see, on this problem, and, you know, the intervals that you're given are going to be different for every test. It's an equally difficult problem either way, no matter how the intervals are done. But the intervals will be -2, -1. And look more closely at the paper. Okay, let's do it right. It's -2, -1, it's open. And then the next one is -1, 0. It is open. And the next one is 0.5, 2. It's open, this end is closed. The instructions say use a different function on this interval than on this one, and a different function on this interval than this one. Now, if I'm doing this with the exponential and ups and everywhere, and if we do this with the exponential in squaring functions. You go to the reciprocal function if you wish. Then you pick one of these on the first interval from -2 to -1. Now the interval -2 to -1, I'll put an orange circle around it, and then I'll kind of draw that interval of the x-axis right here. Oops, I went too far. That's because I didn't do a very good job with my halfway. But right here is -2, -1. Now it's going to include -2. It's not going to include -1. And then we got the interval -1, 0. Okay, that's going to go from -1, 0 over this interval. And it's also open to include open circle. If I wanted to put a blue dot, I could put it inside the orange circle. But a little small to draw a blue circle inside the orange circle, so it's a little grotesque, a little too big. And it's also open on this end. Okay. And then the interval from 0.5 to 2. That's the third interval. I'll use same color in this interval I did on this one. And now this interval starts at 0.5 and it extends to 2, but doesn't include 2. So the interval looks like this. Open here, closed here. Now we pick which function we want to use for this interval, what function we want to use for this interval, and what function we want to use for this interval. Since I'm right now only using the toolkit exponential and squaring functions, I can pick either function for this interval, either f1 or f2, and then the other one for this interval, and then come back to the one I picked on this interval. So we can flip a coin, you know, which way you do it. If we were in class, I'd say, okay, you want to use a squaring function here, thumb up. So I get some thumbs up, thumbs down. I count them and I use whichever one. You can make your choice, whichever one you like better. Okay, so I'm going to use squaring function. That's our f2 of x on the interval -2, 1, meaning that above this interval, I'm going to show you right over picture of the square function. On this interval now, I've got to use the exponential function. So from -1 to 0, there's the exponential function. And I'm going to put an orange circle open and an open blue circle on this point where the two intersect, because this point doesn't apply to either function because we have an open interval here. The squaring function is not going to take a value at -1, not going to have a value at -1, and neither is the exponential function, which means we're not going to have a value at -1. We have a hole in this graph. But since it's only a point, you don't really have a gap. It's like an invisible gap between this section and this section. Okay. Now, between 0.5 and 2, well, we jump all the way over to 0.5, then we got to go back to the squaring function if we don't want to use the reciprocal function. Okay, so their squaring function is going to pick up and down here. It's going to include the point at where x equals 0.5, but it's not going to include this point. So our piecewise function is now sketched in orange and blue. If we want to sketch just a picture of the piecewise function, we go ahead, do our subdivision. And we copy this curve from here to here. That's from -2 to -1. So from x equals -2, x equals -1, we follow the squaring function. Now, the squaring function, we go over 1 down 2. We go from this point to this point, and we would have a bit of concavity. That x equals -1 to x equals 0. And x equals 0 would be the y-axis. We go when I made this picture, I messed up with because square function doesn't go to this point, it goes to this point. Meaning, I've got to trash this video.